Okay, so we need to know what this is. The image. Okay, we talked about this yesterday for a dilation. The new figure is the image. Okay, so remember it has the primes, like triangle. It'll have A prime, B prime, C prime. Okay, that's how you can tell that it's the image, that it has the little marks, okay? The pre-image is the old figure. The original before the transformation. And our scale factor, again, very important, highlight. Image over pre-image. If you flip it, it'll be wrong. So you need to make sure that you have the image over the pre-image. Okay. Okay, so now we're going to review the translations that you guys learned last year in Math 1. Okay, things you're familiar with. Dilation is the new one that we are learning in Math 2. You guys learned translation, okay? Is a terms used in geometry to describe a function that moves an object a certain distance in a translation. Every point of the object must be moved in the same direction. And the same distance along parallel lines. Okay, this is something new. You probably didn't have the notation like this, but this is the notation. Capital T, and then I'll tell you. This, since it's positive, means to the right 6. The -3 is the y value, up and down. It's negative, so you're going to move down 3. So that's what we're going to do here. We're going to take our figure and translate it to the right 6 and down 3. So we just take each point. And we're started point B. I'm going to count to the right 6. So go 1, 2, 3, 4, 5, 6, and down 1, 2, 3. And that's my point. Okay. And then I'm going to label that B prime. I'm going to do that same thing with C. I'm going to take point C. I'm going to translate it to the right 6. So 1, 2, 3, 4, 5, 6, and down 1, 2, 3. And label that C prime. Make it bigger so you guys can see it. Repeat it with D. Right 6, 1, 2, 3, 4, 5, 6. And down 1, 2, 3. And that's going to be my D prime. And last but not least, I'll do the same thing with A, to the right 1, 2, 3, 4, 5, 6, and down 1, 2, 3. And that's going to be my A prime. Now I'm going to connect those dots. So A, B, C, D, A. Now, do those figures look the same? Yeah, right? The same shape, same exact, everything just in a different location, correct? Okay, and that's exactly what a translation does. It just shifts the same figure, congruent figures. Okay. Now we're going to move on. Okay, a reflection is a mirror image across a line of reflection. If you connect the corresponding points on the image and the pre-image, then the line formed is perpendicular to the line of reflection, and they are equal distance from the line of reflection. Okay, to notate this, you'll have a capital R, and then it'll tell you what the line is that you're going to be reflecting across. So you can do the x-axis. You could do an actual equation of line 2x plus 7. Okay, you could do line M. They will name the line. Okay. So this one, we have our line that's reflected across. Okay. What it says that is if you connect D and D prime, it'll be perpendicular to the line of reflection, and it'll be equal distance. So the distance from here to the line will be the same distance from this line to D prime. So these two pieces will be congruent. Remember that little line means congruent. You do the same thing for C. Connect C to C prime. You notice that that's also perpendicular to a line of reflection, and it is also equal distance. You can do that with A as well. A to A prime. Perpendicular, and this is congruent to this. Any questions over that? Okay, then you have a rotation. A rotation is a transformation. In which a plane figure turns around a fixed center point. In other words, one point on the plane, the center of rotation, is fixed, and everything else in the plane rotates about that point by the angle given. Okay, notice they're going to do the notation of a little r now. Then it'll give you the degrees. Are you rotating 90 degrees, 180 degrees, 360, 270, 45? That'd be hard. Okay, and then it'll give you a center point. Okay, if it doesn't have a center point, just like a dilation, it will be about the origin. Any questions over that? Okay. In this case, we rotated this about point B. Or P, I'm sorry. How I show the rotation is I draw like a hinge. So from point B, I draw up and over, kind of like a slope. A rise and a run. It'll be negative if it's going to go clockwise. If it's going counterclockwise, it'll be a positive. So technically, if this was for this one, this would be a negative 90. Okay. Okay, so we're going to rotate that point 90 degrees. So if you just take this, 90 degrees is like this, right? So I'm just going to push this way. So it'll be 2 and then down 1. Does that make sense? If I rotate this way, 90 degrees, My B prime will be right here, which is where it is. I would do the same thing with A. I'd do my rise and my run. If I rotated it 9 degrees this way, I'm sorry, it'd be this and then up to get my A prime. Does that make sense? I'm just taking this hinge now, the blue one, and rotating my 90 degrees and get A. And that's how you can do it for your homework. Any questions? Yes. Yes. It's not changing the distance at all. Okay. Any other questions? Okay. So now I want you to practice this. Okay, use our proper tools. Okay, translation, reflection, dilation, rotation. Did I say that one already? I don't know. Okay, all those. Okay, so try with Helena to see if you can map. Is there a composition of transformations that maps A, B, C, D to the second figure in each student's work? If so, what is it? Okay, so in your pairs, you guys are going to work together and try to see which transformations you're going to need to put A, B, C, D onto Z, W, X, Y. Okay, so what do we think we do to get this onto it? Yes?
I did a reflection across the line between the D and the Z.
Okay, you reflected it?
Yeah, 180 degrees.
Oh, rotated it. Yeah, okay.
And then I got 0.5 for the scale factor.
Okay, so let's define transformation. We're going to rotate. Choose a center point right there. And then I'm going to select all this. Oh, I did 90 degrees, right? We don't want 90, we want 180. Okay, so that looks good, right? Okay, I rotated it 180 degrees around that point. Okay. Might want to label that point. What letter do we want to give that point that we just created? H, okay. Label that point H. Everyone's drawing this right now. Okay. So we drew that point in right here. Like that, right? It's not gonna be exactly. And this was D. This was, oopsie. Okay. After we do that, what should we do? Okay, how big of a scale factor? By 2. Okay, if you can see this edge, it looks like it's twice, right? And what point are we going to dilate it about? What's the center of dilation here? Z, right? It looks like from here, if I elongate here double, that will map onto W. Does that make sense? Because that's like my A prime here Okay, so then we're going to define the transformation. I'm going to have a dilation. I'm going to choose the center point of, oopsie, dilation by 2. Okay, and I'm going to apply there. Let's see. Oh. Hold on, it doesn't like me there. And apply. Oh, it did the wrong thing. Apply. 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 It's taking the whole thing, but you guys get the idea, right? Okay, so that maps it on top. Okay, so in our notes, okay, we're going to dilate this. So this was our A prime. This was our B prime. This was our C prime. Okay, when we dilate it, it's going to be now right here to here to here to here. That makes sense? Now this is A double prime. This is B double prime, and this is C double prime. Because I had 2 transformations here. So we're copying this down into our notes. Okay, so we're going to describe that. So we rotated. Oopsie. We rotated 180 degrees with a center at whatever you want to label that to be, H, I think we said, at H. And dilated by 2 with a center at Z. No, not G. In this case, it would have been D prime. Any questions over that? Okay, so that's how you perform this composition of transformations. So those 2 figures would be similar because they're the same congruent angles and all the sides are proportional. They all had a scale factor of 2. Any questions over that? Now, if we look at Edwin's, you can kind of tell that these are not going to be similar. That you cannot map those over each other. The angles don't quite map. Did some of you guys say anything about Edwin's? Did you guys come up with something you thought you could do? No? Do you think, Caleb? No? Okay, well, I know in last period, a lot of people thought maybe if we reflected it across this line. Okay. Did you guys see that? Looks like you could write maybe reflected over and it would map. Okay, so let's try it and see what actually happens. So we're going to add a transformation. We're going to reflect across this line. And we're going to choose all of this. I'm going to apply. Okay. It is super close, right? But if I blow this up, oh, it doesn't let me. I can't zoom in. You can see that this line isn't exactly on it. That the black line does not go exactly on that orange line, JH. Okay, C, D doesn't exactly go on to H. Because that angle is not congruent to itself. Okay, or it's not congruent to each other. Angle D and angle J are not exact measurements. They're close, but they're not exact. Does that make sense? Okay, so you can't do anything else. And does it look like that they all have the same scale factor? Here it looks like this is twice as big, but does this side look like it's going to need to be twice as big? No. Okay, so it's not the exact same figure. It kind of looks close, but it's not. Any questions over that? Okay. Okay, so let's go on to the next one. If line M is represented by the equation x equals -3, let's draw that first. So we're going to grow where x is -3, which is right here. Okay. This is another point where x is -3. That helps remember that this is going to be a vertical line. Any questions over that? And we're labeled as M, line M. Okay, they want to know what are the vertices of each image after the following transformation has occurred. Okay. So we want to reflect across M. Okay, so let's review how we reflect. So I'm going to draw from B to the line. What's the distance there? A distance of 1, right? So if I reflect it across there, it should have a distance of 1 here, right? And that's going to be B prime. Do the same thing with A. It's a distance of 1, 2, 3, 4, 5. So over here, we should have a distance of 1, 2, 3, 4, 5. And that'll be A prime. Make sense? And then C, same thing. I have a distance here of 3. So I need a distance here of 3 to get C prime. Then I'm going to connect those dots. Oh, good. I did a pretty good job, right? They look exactly the same. I just flipped it over. Any questions over that? Okay, what's the next thing I need to do? What does a D in 0.5 mean? I'm going to make it smaller. Make it 0.5, which is like half as big, right? Okay, so let's make it half as big. It's from the origin, right? So I want the distance from the origin to be half as big. Okay, so let's measure the distance from the origin. So here's my origin. That's 0, 0. I want half as big. So I go and see how far away from the origin is point B. Let's start there. So I go up 1, 2, 3, 4, 5, 6, 7, 8. It's up 8 and over 1, 2, 3, 4. Does that make sense? So you're just measuring it. It's up 8 and over 4. Okay, and I'm just going to take half of that, right? Times this by 0.5, sorry. What's half of 8? 4. So this is going to be up 1, 2, 3, 4. And what's half of 4? 2. So it's going to be up 4 and over 2. 1, 2, 3, 4 and over 1, 2. So this is now going to be my B double prime. And you guys find A. What is this ordered pair over here? What's the ordered pair? 6, 7, 8. This is at -8 and what? And +4. I want half that distance. Okay, so if I multiply that by half, or 0.5, right? What is my new ordered pair going to be? Very good. So I'm going to go where -4 and 2 is. That's going to be a double prime. Does that make sense? Do the same thing with C. See my ordered pair there, or C prime, is at 6 and 8, 10. Is that 11? No, this is 10 here. Oh, it's at 10, right? -6 and 10. I multiply that by 0.5. And I should get -3 and 5, right? So that's C double prime. And this should be my new triangle. Does that look a half as big?
Yeah.
It does. Any questions on how we did that? We're good? Okay, next one. What are the vertices of the image? Dilation of 3, about the origin, and then a rotation of 90 degrees about the origin. Okay. I'm going to tell you that we can't dilate this by 3 because it won't fit on my graph. Because if I dilate 1, 7 by 3, my new order pair is going to be 3, 21, right? Can I graph 21 here? No. So I'm going to start by doing the rotation first. I'm going to rotate it 90 degrees. Oh, and that should have had a little R there. This should have been an R here. I don't know what happened to it. It should to signify a rotation of 90 degrees. So let's write that in. So I'm going to take my origin, and I'm going to draw the hinge. I'm going to rotate it counterclockwise 90 degrees. So this is up 1, 2, 3, 4, and 1. So it's going to be this way. 1, 2, 3, 4, and 1. Does that make sense? And that's going to be my y prime. And you guys do the rest of the rotation. Have you guys do that in your pairs and just check your work. Okay, so this should be x prime at 5, 3. This point would have been at 4, -1. And z is going to end up being at sorry, this is at -4, right? Help me out here. -4, -5. And this is going to be at -7 and 1. And that's z prime. Does that make sense? We're good? Yeah.
So basically, you could flip the x and y in this negative, or flip like the signs too.
Are they both negative? The signs are not both flipped, right?
Oh no, 1, 7. I was wondering because yeah.
You've changed x and y, and the x is negative. The y stays the same sign.
So there's no simple answer.
Well, you can switch the x and y, the coordinates of the x and y, and change the x value to a negative.
Oh,
that's it. That's the rule in this case. Okay? Okay, now I have to dilate this. So what I need to do to all those ordered pairs to dilate this by 3. Multiply them all by 3, right? Okay, so multiply those all by 3. So times 3, times 3, times 3. I'm going to do z first. Is at -21 and 3. -21 and 1, 2, 3. And that's your z double prime now. And then y is going to be at negative, oh, that's a bummer. Oh, -12 and -3. Sorry, I was thinking y was going to have to be 12, and that doesn't go down far enough. Okay, so -12, 10, 11, 12, and -3. 1, 2, 3. And that is y double prime. And then this x prime is going to be at -15 and 9. How we do? Okay, so let's see how we're doing here. Okay, so let's make sure we know what this is. A similar figures, or two figures are similar if and only if the second figure can be obtained from the first by a sequence of rotation, reflections, translation, and dilations. Okay, so we didn't get through all of the notes.